So on your notebook paper, we are going to write one problem, and then we're going to go into your vector applications packet. We're going to do one of your problems together, okay? And then I'll let you try one on your own. So there is a lot of writing because these are word problems. So like, do your hand stretches if you need to. Like, get your fingers all ready. You know, like okay. So here we're going to say Miss Rice is flying an airplane. You didn't know that, but I actually can fly. Nobody was excited about that. Is it because you don't believe me?
Yeah.
True story, though. My dad has his pilot's license. Yeah. No, he's not a pilot. He just had it back in the day because he wanted to know how to fly, so he got a license for it. All right, Miss Rice is flying an airplane. The airplane has an airspeed of 525 miles per hour in the direction north 60 degrees east. The wind velocity is 50 miles per hour in the direction north 45 degrees west.
Can you pause the video?
I'm on like 525 miles per hour.
What is the ground speed and direction? So, the first step when you are working with these problems, and this is a very typical vectors problem, I would bet that there is even a problem worded very similarly to this on your NC final exam. Like, these are very common. And I mean, like, it wouldn't just be a vectors application. I mean, like, specifically with an airplane and wind. Like, this specific scenario is very common. So, first thing we're going to do is we're going to write the vector that represents the airplane. And to write that vector, yo, chatty pants, up here. My turn. The way that we... All right. The way that we start off writing the vector is we take the mileage, which is, the speed of the airplane, which is the same as the magnitude, and we multiply that by cos of the angle plus sine of the angle. Okay, so I'm going to write 525 cos of whatever the angle is times I plus 525 sine of whatever the angle is times j. And the reason I'm not writing the angle as 60 degrees is because that's not the calculator appropriate degree measurement. That's the degree measurement based on a compass. And so I have to translate it into like the math calculator number that we would have. So if I draw a little picture of that, then starting north and going 60 degrees to the east, that would mean that the plane is headed that direction. And so if we were using calculator measurements, what degree angle would we have using a calculator? 30. So that's like our standard position, and we're fairly comfortable with that. We did that before I left. So 525 cos 30, 525 sine 30. Okay? So first thing, we write the vector for the plane. Are we okay with that?
Yeah.
Okay. Second thing, we write the vector for the wind. So the wind is 50 miles per hour, so 50 cos something plus 50 sine something. And again, for the wind, we have to figure out what the angle measurement is in terms of like calculator measures. So this one said north 45 degrees west. So if this is north, then we're going 45 degrees to the west. And the calculator measurement for that would be 135. So 50 cos 135 50 sine 135. Okay. So what we are trying to find is we want to know what happens when the airplane and the wind are combined. Okay? So our next step is we're going to say the vector of the airplane plus wind. And so what we do is we combine like terms. So we're going to take the two I terms and we're going to add those together. And we're going to take the two J terms, we're going to add those together. Okay? So I'm going to say 525 cos 30 plus 50 cos 135 I. That's my horizontal component. And then I have plus 525 sine 30 plus 50 sine 135 J. All right? And this is where I switch over and I'm starting to use my calculator. So I'm going to check the mode of my calculator to make sure that I'm in degrees. And then I'm going to type into my calculator 525 cos 30 plus 50 cos 135. And make sure before you do that that you checked that you're in degrees. All right. So when you type that in, just for the horizontal component, just the first part, you should get 419.308. And I'm going to go ahead and store that as X. And then on my paper, I'm going to write down that I'm storing it as X. Are you guys remembering this from the video notes you had to watch? No. Is this ringing a bell? Okay. I'm going to do the same thing with this over here, and I'm going to store it as Y. Okay? So you can go up and you can grab it, and then all we have to do is go back and change the cos to sine. And again, storing it this time as Y. Okay. Okay. Did we get those decimals?
I got 297.178.
You have a typo somewhere. All right. How are we doing? Okay. So go ahead and move your calculator off to the side. Don't mess with it, though. We want to keep those numbers. And we're going to draw a picture of the vector addition that we just did. Okay? So, and you're going to draw it kind of big so you can refer back to it later. So we have the plane, and the plane flew north 60 degrees east, and so the plane flew this direction, and the speed of the plane represents the magnitude of the vector, and the magnitude of the vector is the length. So a speed of 525 means that I'm drawing a long vector, okay? So I'm drawing this vector a length of 525. This is the vector of my plane. All right? Can you shut the door for me, Damien? Thank you. We're trying to learn. Yeah, vector of the plane. Actually, I was using A for airplane. And then I switched it to a P. That's very confusing. Sorry. Okay. Vector of the airplane. Okay. And then at the end of this, I'm going to draw a little X and a Y axis right here. And from here, at the very end of this, if you guys remember when we do vector addition, wherever you end the last vector is where you start the next one. You guys remember that? So this is where we ended the vector of the airplane. We're going to add the vector of the wind. The vector of the wind, if this is my x and y axis, it went to west, so northwest 45 degrees, it went this way. And it was a speed of 50 miles per hour, which means it's a length of 50. So if this is 525, that's really long. And this one's 50, that would not be very long at all, right? In relationship to the other one. So I'm going to go ahead and say like the wind is going 45 degrees west like that. 50 is like about that long, just not very long at all. So that's the vector of the wind. And then do you guys remember how we draw the resultant vector? You start at the beginning and you draw it to the end. All right? So this one right here, I'm going to go ahead and do it in red so you guys can see it. This one right here represents the vector of the airplane and the wind combined. All right? Does that make sense? Okay. So when we look at this, and you can see that that matches the information for your vector, it goes right and it goes up. It's a positive number for the horizontal component, positive number for the vertical component. Makes sense that this would be in the first quadrant. Positive x coordinate, positive y coordinate. Okay? So now that we have that picture, we're going to go ahead and find the speed and the magnitude of the resultant vector. So the speed and the magnitude are the same thing. That's just the length of the vector. How do we find the magnitude or the length of a vector? It's the double line thing. And what do we do with these two? You have a big square root, so we're going to say the magnitude, aka the speed, is a big square root sign. And what do we put in the square root? Yeah, the number we stored is x. So we're going to say 419.308 squared plus the y, 297.855 squared. But we don't have to type those decimals in because we stored these as x and y. So what we are going to type in our calculator is we're going to type in square root of x squared plus y squared because we stored those numbers. So square root of x squared plus y squared. That's what I'm typing in. Okay. All right, so what did we get? Okay, and what are the units on this? This is the speed. Miles per hour.
Would it be squared or just like that?
Miles per hour. All right. So if the plane was originally going 525, the wind is pushing against it, the wind slowed down the plane a little bit. Does that make sense? Okay. If the wind was pushing it in a similar direction that it was already flying, then the wind would actually make it go faster. But in this case, the wind was pushing against it, and so the wind slowed down the plane. Okay. Reasonable answer. Would 102 miles per hour be reasonable? No, that'd be a really weird answer. Would negative 59 make sense? No. So there's these problems are nice because your answers need to be reasonable. There's a point where you'd look at an answer and be like, yeah, that can't be right. I made a mistake. Okay? All right, next we're going to go ahead and find the angle of the plane. And so to find the angle that the plane is flying, we always use the formula tan theta equals y divided by x. Tan theta equals y divided by x. So if you guys remember back when we dealt with the unit circle, we always knew that the tan was the y coordinate divided by the x coordinate. And so we're going to use tan here so that we can find the theta since we're given y and x. So we know that if that's the formula that we're using, then theta equals tan inverse of y over x. All right? So in our calculators, we know that theta is tan inverse of 297.855 over 419.855 35.308. But we don't have to type those decimals in because we can use what we stored for y and what we stored for x. So we're going to type tan inverse of y divided by x. So the nice thing is if you use x and y every single time, then you're basically just typing the formula into the calculator every single time. So it'll always work out the same way. So that means that theta is approximately 35.388 degrees. And this is the calculator measurement. This is not using a compass. This is using our calculator. So this is not the final answer we're going to use. This is calculator appropriate numbers. But if we look at this, does it make sense that our original angle was 30 and our new angle is more than that? Yeah. So originally the plane was flying at 30, the wind pushed it, and so now it's flying at 35.388. Now the angles for this particular problem were written as north something west or north something east. So would this be a northeast or a northwest? This is a northeast, so it's north something east. How do we figure out how far to the east it was from straight north? 90 minus the 35. Okay, so we're going to say 90 minus the answer we just got. So it is north 54.612 degrees east. All right. So now we just go ahead and we take those answers, we write them in a sentence. Now what I'm going to ask you guys to do on these application problems is when you're doing the math, write the decimals, the 3 decimal places. When you write it in a sentence, you can go ahead and just round to the nearest whole number because nobody knows how fast a plane is to 3 decimal places. Nobody says like, today I'm driving in my car 35.872 miles per hour. Right? No, you sure don't. So we're going to say the plane, or they said the ground speed. Ground speed is when you're actually looking at the plane. So like the plane, when it flew 525 miles, that's like how fast the plane was trying to fly, but the wind slowed it down. Does that make sense? So the ground speed of the plane, if you were on the ground, like tracking the progress of the plane and it's fighting against the wind, the ground speed of the plane is 514 miles per hour. All right, so we're going to say the ground speed of the airplane is 514 miles per hour. And then we say in the direction, to say what angle it's going, in the direction north 55 degrees east. North 55 degrees east. The ground speed of the airplane is 514 miles per hour in the direction north 55 degrees east. Okay. So this process is basically 5 steps. I don't remember how I said it in your, I want to be consistent with your notes, but I don't remember how I said it for the notes. So here's basically the steps you need. The first step, you write the vector for the plane. Second step, write the vector for the wind. Third step, write the vector for the airplane and the wind together. Fourth step, find your new magnitude, which is your new speed. Fifth step, find your angle. And then I guess you could say the sixth step is to write the sentence. Does that make sense, how we walked through that?
Yeah.
So find one vector, find the other vector, add them together, find their magnitude, find their angle, sentence. It works like that every single time.
You found the angle is always 90 minus whatever?
No. That was just because we were in a first quadrant and it was based off north. But it's possible for your plane to be flying in the 4th quadrant or the 3rd quadrant and it would be different. Okay. Go ahead and grab your vector applications packet. vector applications packet. All right, look at your vector applications packet. We're going to do number 10. Hector, if you want to go to the bathroom, now you can. All right, number 10 in your vector applications packet. Vector applications. You guys took your notes on the first page.
Can I go after this?
Yeah. So this is what it looks like.
Oh, yeah.
Vector applications. When you took the notes, you should have filled out the first page when you took notes on it. Okay? This is the homework from Thursday. From last Thursday, it was the homework.
Oh, yeah. I was
Okay. All right. So, if you're looking at number 10, it says an airplane has an airspeed of 600 kilometers, and it's bearing, I shouldn't have said bearing there, but I did, south 30 degrees east. So I'm going to go ahead and draw this using my compass angle so I can figure out what calculator angle I really should have had. So south 30 degrees east. So south 30 degrees, that's 30. So if we were to do the calculator measurement for that, what would that be? Okay, 300. So the vector for the airplane is 600 cos 300 degrees, I, plus 600 sine 300 degrees, J. This is 30, and that's the 300. All right, we also have the vector of the wind. It says the wind is 40 kilometers per hour in the direction south 45 degrees east. So south 45 degrees. It's 45 right there. So in calculator measurements, this would be 315. Okay. So how do we write that vector? The speed was 40. The angle is 315. Okay. Plus okay. So we have the vector of the airplane, we have the vector of the wind. What do we do next? Add them together. You can still be blessed after you've hiccuped. It's still important. All right. So we have the vector of the airplane and the wind combined. What do we do with that? Not yet. We are going to do that next, but what do we do next?
Put it in the calculator.
Put it in the calculator. Yeah. All right, so I got that. That's my first coordinate, and what do I do with it on the calculator? Store it as X. Okay. Now what do I do?
Now you add the 600 sign. You're going to store that as Y.
So I'm going to type in the sine part. This one says minus. I went up where it was dark on it and I pressed enter. And that pulls it down. Yeah, that's negative. So what does it mean if the horizontal or if the vertical component is negative? It goes down. Yeah, it just means that the vector is going to go down instead of up. And 899 followed by a 5 rounds up to 900. So we had 899 rounds up to 900. Okay. So I'm going to go ahead and draw a picture of the scenario. The picture helps when you're finding the angle at the end to make sure that your answer makes sense. And you'll see that not on this problem, maybe on a different one.
Thank you.
So we have a plane that's flying 30 degrees east of south. The length of the vector is 600, so that's pretty long. And then the wind is 40, so it's not very long, and it's right in the middle. It's a 45-degree angle. There's a length of 40. So do you think that the speed of this airplane is going to be faster or slower?
Slow.
You think it slowed it down?
A little.
A little bit because
It's pushing against it a little bit. Okay. I think it might make it faster. We'll see, but I think it might make it faster. All right. So this is the velocity of our airplane. This is the velocity. So not the velocity. The vector. Vector of the airplane. Vector of the wind. And then this right here is the vector of the airplane plus the wind together. And it fits the information we found. It does go to the right and it goes down. To the right and down, which is what we expected. Okay. Now what do we do? Yep, so speed. And this part we can start to shorthand stuff. So I'm just going to say square root of x squared plus y squared. I'm not going to write out the numbers this time. And the units are kilometers per hour. So since the wind wasn't pushing against it too hard, it actually sped the plane up. It made it go faster. Okay, and then what do we need to do to find the angle? Okay, so we're going to say theta is tan inverse of y divided by x. So that means that this angle right here was a negative 59.071 degree angle. Makes sense. Now, the problem, we always make it so our angles match the notation of the problem. And so this problem said southeast and southeast. So our answer should be southeast. So it's something south, something east. So we need to figure out if it, instead of being direct south, how far east it must have been from that. So we can't use 59 as our answer. What do we have to do? So south, however many degrees east. That's what we got to find. We need to know what this angle is right here. Yeah, we could do 90 minus, and it wouldn't be really minus, it'd be kind of like plus because it's already a negative. Does that make sense?
Yeah.
So we just want to figure out how many degrees you could add, like put in right here that would make it to figure out the other angle. So I'm going to go ahead and say 90 plus the second answer. The reason I'm saying plus this time is because the angle itself was already negative. So I don't want to minus it because that would make a much bigger angle. So that would be 30.929 degrees east. So as we're writing down the math in the middle of the problem, we're using 3 decimal places. And then when we write our answer in the sentence, we can go ahead and round to whole numbers. So I'm going to say the ground speed of the plane is so 639 kilometers per hour in the direction south 31 degrees east. So the ground speed of the airplane is 639 kilometers per hour in the direction south 31 degrees east. Do you guys see how repetitive the problem is?
Yeah.
Okay. So when you're done with this one, I want you to try number 9. We're going to go ahead and try number 9.